All right, we're going to move on to multiplying functions. We're going to have a real world context to this one so we can kind of think about that domain a little bit more. So our example, the demand D in units sold for a company's new brand of cell phone at price X in dollars is D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? So they gave us a little formula kind of to follow here. Revenue is going to be equal to the price times the demand. So we are going to define our price function, our demand function, and then we will define the revenue function by multiplying those together. So first, our price function. So let's talk about the price. Price, P of X, we'll define that as P of X, and they told us that the price is X right here. So that's just equal to X. We are going to also talk about the domain as we go along here, so maybe we'll just have a column for domain. So normally when we look at, if our function is just an X, the domain has all real numbers. There's no restrictions there. However, this has context now. It's actually representing the price in dollars of a cell phone. So what kind of prices can cell phones have? Can they have positive prices, zero prices, negative prices? So in this case, the price can't be negative. So that means that our x's all have to be greater than or equal to 0. So there's our domain for our price function. All right, let's go ahead and define the demand function. Oops. So demand, we know, they actually told us up here what it is. The demand is D of X equals 5,000 minus 10X. And when we think about domain for a demand, similar to the price, your demand can't have a negative value either. So let's just make a note that the demand can't be negative, just like the price can't be negative. And our demand then is 5,000 minus 10x. If that can't be negative, that has to be, oops. Oh, it can't be negative, so we're letting it equal 0. Okay, so it has to be greater than or equal to 0. And then because our domain is in terms of x, we're going to go ahead and solve this for x. So let's subtract 5,000 from both sides. Maybe I'll write this over here. That leaves us with negative 10x is greater than or equal to negative 5,000. We're going to divide everything by a negative 10. When you divide both sides of an inequality by a negative number, it's going to flip your inequality. So our x has to be less than or equal to a positive 500. So there's the domain for the demand. All right, now we can talk about the revenue. So let's define our revenue function. The revenue is defined as R of X equals its price times demand. So let's go ahead and multiply that out. Our price function is X times our demand function is 5,000 minus 10x. And then we're just going to simplify that. We can go ahead and distribute that x. We're going to get 5,000x minus 10x squared. And that is the revenue function. It's price times demand. So 5,000x minus 10x squared. The domain for the revenue, let's just make a note that the domain is going to be the intersection of the domains of our P function and our D function. So it's the intersection of the domains of your price and your demand domains. So our price, x's have to be greater than or equal to 0. In the demand, x's have to be less than or equal to 0. So that x is falling between 0 and 500. So we're going to say 0 is less than or equal to x is less than or equal to 500. That is the domain for the revenue. So what is the expected revenue? Let's just sum it up. R of x is equal to 5,000x minus 10x squared. That's what we got up here when we multiplied them out, and we will identify that the domain is 0 is less than or equal to x is less than or equal to 500.